All right, so we're going to start 8.3.2, and from our previous one, we knew that it was a times x equals b, which I showed right here. And that was where we used multiplication now for equations. And what we also have is our ability to just take that equation and to flip it around, so b equals ax. So instead of a times x equals b equals a times x. The reason I rewrote that today is because our focus today is all about distance, rate, and time. And I know I'm kind of peeking ahead here, but in this case, this is how it's going to look today. Distance, that is not what I want right there. Sorry about that. Distance equals rate times time. And so for our problems today, distance is our B, rate will be our I. A will probably be more T, and X will probably be our rate, actually. It doesn't matter, really, which one comes first, but that will be kind of our focus here for today. Okay? So, Axel's getting his pig ready for the pig race at the county fair. During the race, 4 juvenile pigs run along a straight track, trying to be the first pig to get to a cream-filled chocolate cookie. His pig Hammy can run at a rate of 11 feet per second. At this speed, how far will Hammy run in 3 seconds, in 5 seconds, in 1 minute, which is the same as 60 seconds. So, if we were to set this up, if we were to just say, hey, you know what is it for 1 second? Well, in 1 second, we already found out that it was going to be 11 feet, right? Well, then in 2 seconds, right, we're going to have to go for 2. We'll have 22 feet, won't we? And in 3 seconds, we would have 33 feet. So we know that for 3 seconds, we have 33 feet. What would it be for 5? And then in 1 minute, which is 60 seconds? Well, the pattern here is obviously taking the amount of seconds, in this case 5, and we're going to multiply by our rate. Right? 5 times 11 to get 55 feet. And for 1 minute, which is 60 seconds, we will do 60 times 11. Now, if you've been watching the mental math videos, we can just use the trick, right? When we multiply by 11, and then 6 plus 0 is 6. So 660 feet. Okay? All right. Write an expression that represents how far Hammy will run in X seconds. So we kind of did that already, right here. So let's just put that down here. It's our seconds times our rate, or in this case we'll just say an expression is our 11 times our 5 represented time. Okay, oops, that's supposed to be in X seconds. Sorry about that. There we go. The racetrack at the fair is 150 feet long. Draw a diagram that shows how long it'll take Hammy to finish the race. So we have the whole length here, and the whole length is 150 feet, right? And for that 150 feet, we just know that for every second it takes 11, that it's going to take, for every second it's 11 feet, right? So, we can just say, okay, here's 11, 22, 33, 44, 55, 66, 77, 88, 99. Then we get to 110. I probably shouldn't have wrote those so big. 110, 120, 130. I'm sorry. 110, then 121, then 100, and man, I just threw myself off. We were at 110, and then 110 went to 121, then 132, then 143, and then obviously I'm going to exceed that, right? So somewhere within this 11 it falls. And I didn't do a very good job of giving myself a ton of space, did I? While you're watching this, you can write a much better diagram than I just did. So we're going to write an equation to represent this situation. Well, I already kind of gave you some of that stuff up here from the distance equals rate times time. And we already have our part of that right there. So we got our 11x. And what do we need that to do? We need that to represent 150 feet, right? So how long will it take to do that? Well, we need to undo multiplication with division. Right? Undo that multiplication with division. About how long will it take Cammy to finish the race? Well, we're going to take, we're going to just actually take and do that division. 150 divided by 11. We're doing that multiplication with division. And when we actually do that division, I'll let you guys do that math then on your own. What it turns out to be, it says between 13 and 14 seconds, which we already knew. And I believe, if I remember right, it turns out to be 13 and 7/11 of a seconds. Okay, if you do that division. AJ and her sister are entering a 200-mile bike race on their bicycle built for two. On a training ride, they traveled 60 miles in 2.5 hours. They want to use this information to find how long it'll take for them to finish the bike race. Draw a diagram for this situation. Be ready to explain how you found your solutions to the questions below. What is their bicycling rate? So their bicycling rate is 60 miles in 2.5 hours, right? What's their unit rate? Now, we worked on that unit rate earlier in the year, but essentially we want to know what is it per 1 unit or per 1 hour, right? So what we need to do is we just need to take 60 and divide it by 2.5. When we do that, we should get 24 miles in 1 hour. Unless you do that math just to save time on the video. How far can they go in 3 hours, in 6 hours? Explain how you know. Explain how you can use the rate of travel and the time to find the distance. Well, we're going to kind of use that same thought process here, right? If we gain 24 miles in 1 hour, what would we do in 3? Well, that's going to be our 20. Whoops. That is going to be our 24 miles times 3. Just like the pig. I'll get rid of the miles just for confusion's sake. Just like our pig race that we had up above, right? When we wanted to know how far did they go in 3 seconds, 5 seconds, 60 seconds, that's all we're doing. So 24 times 3, that would give you 72 miles, right? And if we do the same thing for 6 hours, we're going to get 144 miles for 6 hours. And then how can we use the rate of travel and the time to find the distance? We already talked about it. It's the rate times time, right? That's what we did. If they bike 10 miles, how long will it take them? Explain how the distance and rate help you find the time. Well, if they biked 10 miles with the same rate, we would then instead say that it is 24. 24 is our rate, right? Times time, we don't know what it is, and it's how long did it take for them to do 10 miles. Undo that multiplication with division, right? So we would take 10 and we will divide it by 24, and then we just need to simplify. Divide it both by 2 and we get 5/12. 5/12. Well, we can actually think about a clock, right? If we think about a clock, that's probably a lot more round than that thing, right? There's a 12, right? We got the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. There's 12, right? Well, it's already broken into 12ths. We need 5/12 of that. So 5/12 would be 1, 2, 3, 4, 5. And that, how many minutes would that be? That would be 25 minutes. Is 5/12 of an hour. And then explain just how the distance, and rate helped you find that. Well, we took our distance and we divided it by our rate to help us get that. If they bike for the same rate for the entire race, how long will it take them to finish the 200-mile race, right? Okay. Well, same process, right? 24 times t equals 200. If we undo multiplication with division, and what do we get out of that one? That one turns out, if you do that, that division turns out to be 8.3 repeating hours. And if that's 8 and 0.3 repeating, that's going to be hours. This is also the fraction of 1/3, and 1/3 of an hour is taking basically our 60 minutes, right, and dividing it by 3. So that'll be 8 hours. And if we take take 60 minutes and divide it by 3, we get 20 minutes, right? 20 minutes. There we go. Summarize in words the relationship between the distance the girls travel, the rate of travel, and how long they ride. And really it boils down to these 3 key equations. And really I just mostly care, do you know this one? Distance equals rate times time, which I cheated and gave you a long time ago. These other 2 I consider kind of bonus. And here's the bonus too. Rate equals distance divided by time. And here's the other bonus one. Time equals distance divided by rate. Okay, so those are the key ones that we get out of that. Okay, a new high-speed train travels 300 miles in 1.5 hours. Louis and Omar are trying to figure out how they can find the distance the train has traveled after any number of hours. Omar decided to draw a diagram to help figure out the problem. He drew the diagram below. That was nice. Good start there at least. Find a unit rate in miles per hour for the train, then copy and change Omar's diagram to show the unit rate. Well, the unit rate was just like we did in the previous problem, right? The original rate was 300 over 1.2, and we need to find that for 1 hour, right? And when you reduce that, you get 250 miles in 1 hour. So if I were to rewrite that diagram, right, here's my 0 hours, and now I'm going up to 1 hour and 2 hours, right, dot, 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 sort of a thing, right, up to t hours. How does our mileage change? Well, this is 0 miles. This one's going to be 250 miles, and this one will be 500 miles, right? I know they kind of put it just a little bit different, like the brackets of stuff, but it's same thing. And d miles there, okay? How far will the train travel in 5 hours? Well, we can already see that it's increasing, right? How is it increasing? It's increasing 250 each time, right? So what we could do is take that 250 and we can multiply that by 5, and then we're going to find out how far will the train travel in 5 hours. We can just do that to get, actually asks us to write the equation to represent it. So rate times time, so rate times time equals distance. So that's really our equation. And so then 250 times 5, that one turns out to be 1,200. Oh man, that's gross. Sorry. 1,250 miles. Okay. Work with your team to write a general equation to show the relationship between distance, rate, and time. Is there more than one way to represent this relationship in equation? I kind of showed that one earlier, right? How far will the train travel in 5 hours? We just kind of put that whole equation together right here. Okay. I may have even jumped the gun when I put it together up here. I guess this one was more in words. I put it in equations. These equations we could have kept going. Put it really here, I suppose. Okay. All right. In problem 8-97, you wrote an equation to relate distance to rate of travel and time traveled. What if the rate does not involve distance? Use the situation below to investigate this question. Fred was filling bags of food for families in need in the neighborhood food pantry. Very relevant to today's world. Fred could fill 6 bags in 15 minutes. Draw a diagram for this situation. Be ready to explain how you found your solution. So, how many bags could Fred fill in 2 hours? Well, 2 hours, right? 2 hours is going to be 120 minutes. And so here's 0 minutes and 15 minutes, 30, 45, 60, 75, 90, 105, and lastly 120, right? Well, if it's 6 bags, then it's 0, 6, 12, 18, 24, 30, 36, 42, 48, right? 48 bags. How many bags can Fred fill in 5/6 of an hour? 5/6 of an hour. Oh, well, 5/6 of an hour. If we look up above, right? Here's 1 hour here. This would be 1/4, a half, and 3/4 of an hour. Well, 5/6 is actually going to be kind of fall somewhere in here, right? That's what we're going to do. And so what we find out is how many bags can we fill in 5/6 of an hour. Whoops. We are going to find out that we use that rate of, I could even use the rate of 24 bags in an hour, right? 24 bags in 1 hour. 24 times, let me make sure I got this right here. Yes, there we go. 24, right? That's my rate. And I'm going to do it for a time of 5/6, right? So it's kind of like rate times time equals distance. But in this case, I don't have distance. I have equals bags. Okay. So 24 times 5/6. And when we do that multiplication and you simplify it with that division, you will get 20 bags. 24 times 5, and then divide it by 6. Write a rule to generalize the relationship between the number of bags Fred can fill and the amount of time that he works. So, rate times time equals bags. And we would really want to define our variables, so I kind of define them there. I just say rate times time equals B, where B represents bags, right? All right, what else do we got here? I just had one thing I forgot. If it is for Fred, I guess we already know the rate, and we could say 24 times T equals B, right? All right. Use your equation for part C to find the number of bags Fred will fill during a week, assuming he fills bags at a constant rate and that Fred works 36 hours in a week. Okay. Well, we know that it is 24 bags in an hour, right? And it is for 36 hours, right? So we'll use our same thing we did before, 24 times 36 to equal our total bags, right? And when we do that, we get 864 bags. Here's an extra problem, not something you must do. Claudia and her cousin Brian, man, it's getting late, I can't even talk, often ride their bikes to meet each other. They live 16 miles apart. Claudia can bike at a speed of 8.5 miles per 1 hour, and Brian can ride 11 miles per 1 hour. If they leave their home at the same time and bike toward each other for half an hour, will they meet? So I have Claudia. We'll do Claudia in blue. And in 1 hour, she has 8.5 miles, right? But for 1/2 of an hour, right? How do we know that? There it is right here, half an hour. We're just going to take half of that. Well, that's going to be 4.25 miles. So what we need to do is also do Brian's. Let's see what he does in that half hour. Well, Brian's a little bit quicker, apparently. He has 1 hour, and he's 11 miles, right? Well, what is he for that half hour? Well, 1/2 hour, a half of 11 is 5.5 miles. All right, well, let's just put these two together. Right? Put these two together. And when we put those two together, will they meet? Will they meet? Well, 5 plus 4.25 is 9.75 miles. Right? Will they meet? The answer to that is no, they won't, will they? So, all right. I think Learning Log, I very much encourage you just to kind of write. It helps to kind of clear some of your thoughts, especially if you're a writing type person, right? Distance, rate, and time. We talked about this. This is a great summary. Read this, right? Read this. It just kind of does a good job of going over those things that we did earlier, okay? Answers if you need to check some stuff. And then, again, I encourage you to show your work, right? Show that work. If you have any other questions, please let me know.